Hi, ladies and gentlemen. Welcome back for 10.4, Graphing Rational Functions. So in yesterday's notes, the first part of Graphing Rational Functions, we talked about holes and vertical asymptotes. And both of those came from excluded values in the domain. And I mentioned that we'd have horizontal asymptotes today. And so horizontal asymptotes come from the range. So that's the y part. So when we talked about vertical asymptotes and holes, we looked at excluded values for the x. Domain is x values. So we looked at things that we couldn't have x be in our denominator. But because today we're talking about horizontal asymptotes and they come from the range, that deals with the y. And so we are unable to use, just like looking at the function and finding the x value like we did yesterday, we have to do something a little different for the y value today. So we are going to actually use GeoGebra. And so you can just Google GeoGebra, or if you got the notes, you got the website written in there. And so we're going to go in and use GeoGebra to help us with our functions, and we're going to graph them. So there are 6 of them. And so I'm just going to show you how we want to graph our first one. And so it's y equals x minus 1 divided by x minus 2. So I have to put a parenthesis in, and then I have to do my x minus 1. And then I want to arrow over, so I'm over that. And then divide. If I don't put that numerator in parentheses, it's going to do x minus 1, and then I'm going to divide just the one piece by that. And then, here, I'll show you. So x minus 1. And then I hit divide. See how it just does the fraction piece? So we need to actually put those parentheses in so that we can have it now do fraction. And then we also need to do x minus 2 in my denominator. And then that one will graph, we hit enter, that works too. So we're looking for horizontal asymptotes. Now I'm going to zoom out a little bit so you get an idea of what our graph looks like. So we see that it has this shape. We've seen graphs like this before. And yesterday we talked about vertical asymptotes, and that dealt with our denominator. And if you look, when we go close, my vertical asymptote is at 2, because that's what makes that 0. Now, if we look at where is it approaching, either on the left side or the right side for our horizontal asymptote. And the nice thing about GeoGebra is you can grab it and move it all around. So I'm just scrolling in, and then see now my 1 has appeared. And I'm approaching 1. Great thing is that these values here aren't going to disappear. So my horizontal asymptote here is going to be 1. So I'm going to write that y, oops, let me do that again, y equals 1. All right, so I want to change it into my 4x minus 1 over x minus 1. So I'm going to go back. Oh, nice thing, hit home, and it takes you right back to that origin. So if I click up here, and now I can use my mouse and just put right in front of there. So 4x minus 1, and then I can click in the denominator and delete and put my 1 there. Now I do want to hit enter so that it changes my graph. So again, if I zoom out, we see that shape we're very familiar with. And you can look here, we are approaching x, not x, 4 for both of these. So I'm going to have y equals 4. All right, I want you to go ahead and pause here, and I want you to try problems C and D. Okay, try problems C and D. All right, so hopefully you took some time and put in problem C and problem D and took a look at your graphs, and we can see that we have y equals -3 for C, and we have y equals, I'm going to squeeze it in there, -3 in for D. So both of those ended up being -3, even though those problems are different. All right, so I am going to show, let's jump here. I actually want to jump to F. I'm going to show you F just because it's got a cube, and then you can go on and try E here in a moment. So I'm going to show you F because it's got a cube. So if we look, I have to change that to a 3. Now, in my buttons in this part, I have a box with a 2. That makes it a squared. And then a reason why I want to show you is the cube one is because we want to use this where it's got that space, and then I can put cube or fourth or whatever. So now you've seen where squared and cubed come from. Okay, and then we can change that to a plus 5. And then my denominator, I want to change to x cubed. So I'm going to go down and use that fancy button again. And then I'm going to arrow over and change that to minus x. And hit enter. So my graph changes. And if I zoom in, now I'm going to see here my graph is going to give me a 3. There, it pops up. Now, I'm not sure why, and I'll have to check on this, why we're going to go over 3 here, because when we graph it on our graphing calculator, it doesn't. But I'm going to look at this side. It's going to approach 3. So my y is approaching 3. So that's going to be my horizontal asymptote here. So go ahead and try E and come in back, and then we'll talk about that one. All right, hopefully you graphed E, and we get that to be y equals 1/2. All right, so the question says, looking at the given functions, what is a common characteristic of each? Hint, consider the degree of the numerator versus the denominator. Is there a pattern? All right, so if we look here, and taking a look at that, all of them have, it says consider the degree, the exponent. So I have an x over an x. I have a 4x over an x, 6x, negative 6x over 2x. So their exponents are all the same. They're all 1 in here. Here they're both squared. Here they're both cubed. But that pattern holds true whether their exponents are 1, 2, or 3, is that my coefficients reduced is going to be what my horizontal asymptote is. So look here at B, I have 4 and I have 1. So 4 divided by 1 gives me 4. D, I have negative 6 divided by 2, that gives me negative 3. Here I got 3 divided by 1, that gives me 3. So what's a common characteristic of each? It's going to be the coefficient. Now I'm writing it on my my computer, guys, so it's kind of sloppy. Let's erase that. Try again. Coefficient. There we go, coefficient. So if we look here, how would you find the horizontal asymptote of this function? So they both have just an x for my variable. And so 8 divided by 2, I'm going to get y equals 4. All right, so let's go ahead and jump to the backside. We see these 4 problems. I'm going to go ahead and put our first one in to GeoGebra. So I had clearing out to do here. X minus, just x, and my numerator. I delete all that and just pop a 1 in there and hit enter. So again, I'm just going to hit my home button. Oh, there we go. So if I look, again, very familiar. And if I zoom out a little bit, you can see that if that's 2, 1's got to be about here. So these horizontal asymptote, it looks like it's at 0. So I'm going to write y equals 0. All right, I want you to pause here and I want you to try all 3 of these and see what happens, what you get for a horizontal asymptote. All right, so hopefully you'll pause and now you're back with us. And so if we try all of these, we see that every single one here, the horizontal asymptote approaches 0. So our horizontal asymptote, y equals 0 for all of these. So now we're going to ask the same type of question. Looking at these functions, what is a characteristic, a trait that we can see that's going to get them all into 0? So if we look at our degree of the numerator versus the denominator, here we see we have no x and an x, no x and an x. Remember, x to the 0 power is going to be what we could have in the front top there. In problem C, we have an x over an x squared. Here we have an x squared over x to the 4th. So in all of these, our denominator has the higher exponent. The numerator is the smaller exponent. So all of those go to y equals 0 for our rule. So if we look here, my numerator has a power of 1 and my denominator has a power of 3. So the exponent is higher. So that's going to give that a y equals 0. Y, not x. Again, writing on the computer. All right, so let's try the next chunk here. So graph these ones in GeoGebra. So I'm going to go back in and I'm going to change, and I have x squared. So x, I can use my little square button. And then I have minus 3x and a minus 1 over just x. So if I hit enter, ooh, this one looks like it might be different. So if I look at it, bring it over a little bit more, notice there's no horizontal asymptote for this problem. I do have a vertical asymptote at 0, but I have no horizontal asymptote for this problem. Okay, you got 2 more. I want you to put both of those in and see what happens. That's a poor N. There we go. Okay, so did you pause and try those? Hopefully you did. Now let's go ahead and look here. What's the common characteristic here? Again, we're going back to what's the exponents. If you look in these problems, all of these, the numerator, the top of our fraction, has a higher exponent than the denominator. And all of these ended up with no horizontal asymptotes. So all of these have none. So we have this nice little table chart. Oops, sorry. Let's try that last problem there. It has a higher exponent in the top, 3x to the 4th, and we have 4x squared. So this is going to be a none for our horizontal asymptote. Great, so we have this little table here, and it says case 1, the degree of the numerator is the same degree as the denominator. These are the first problems we worked on, and this is y equals my coefficients. And remember, it's your coefficients reduced, simplify that fraction. In case 2, the degree of the numerator is less than the degree of the denominator. So that means that the denominator has a bigger one. So we get y equals 0. And then case 3 is when our denominator has the smaller exponent and the numerator has the larger exponent. So we get none. Now, my little handy thing that I write when I do my homework, so that I have a little cheat on my sheet, is x over x. So this is where they're the same. My horizontal is my coefficient. Then that says the degree of the numerator is less, so that would be like x over x squared. This is when I have 0, y equals 0. And then the last one, the degree of the numerator is bigger. So if I have x squared over x, this is when I have none. So maybe jot that little piece, not in your notes, write that on the top of your homework to refer back to when you do your homework. All right, so let's go ahead and move on to our first problem. Now, that's the only new piece. Everything we did now, from here on out, we're going to identify the horizontal asymptote, the vertical asymptote, the holes, vertical asymptotes, holes, graphing. We did that all yesterday, so that's not anything new for us. All right, so let's go ahead and look here. I start off with, let's look at our horizontal asymptotes. I have x on top and x on bottom, so if they're the same, my horizontal asymptote is just going to be my coefficients. So I have 1 over 1. So y equals 1 is my horizontal asymptote. Now I'm going to go to my denominator. I would end up with x equals 3. Now I asked myself, can I cancel it with anything in the numerator? And I can't. So that makes this my vertical asymptote. And then I have no holes in this graph. So you just write none in that spot. All right, then go ahead and go to your graphing calculator and put this into the table, your original function into the table, y equals, and get a table. Okay, pause it here so that you can fill in your table values. All right, so take a look. Hopefully you got the same table values that I have. We want to go to graphing it. Now I have a horizontal asymptote at 1, so I want to draw that in on my graph. It's a boundary. And I have a vertical asymptote at 3. So 1, 2, 3. And you want to draw that in dotted on your graph also. Okay, so now go ahead and pause the video here and graph these points. All right, so I have graphed my ordered pairs. We see that curved shape in the 2 quadrants, and we have them approaching our asymptotes. Awesome. All right, this problem here, let's go ahead and look. I have no x in the numerator. So that'd be like an x to the 0, and I have an x to the first and the bottom. So my exponent is smaller on top and larger on bottom. So therefore, I have y equals 0 for my horizontal asymptote. If I look at my denominator, x would be equal to 0. That does not cancel, so that makes that my vertical asymptote. So I have vertical and horizontal asymptotes on the 0. So one dot on there and here. I like to use a different color marker or pen on my homework when I make my answer keys, just so that I can see that those are there as boundaries. All right, I want you to pause and do your table and your graph and then come back and find out if we have the same. All right, so there we have it. Now, some people ask Miss Masson, like, how do I decide what I should make for my table? Because Miss Masson, you don't always give me a table. Great question. So when I decide what values I want to do for the table, I look right here at my horizontal asymptote, my vertical asymptote. I want to pick 3 to 4 values to the left and 3 to 4 values to the right. And that is going to help me show me what happens on the left side of the graph and what happens on the right side of the graph. So about 3 to 4 on both sides of my vertical asymptote, so like here, and then that just helps me see what happens on both sides. All right, let's go ahead and go to problem 6. Okay, and so in problem 6, I have some simplifying and factoring I'm going to do. So I have x squared minus 16. So that's a difference of perfect squares I have to do. Oh, you know what I should have done before that? How about we do some horizontal asymptotes? So if I look, my numerator has x squared and my denominator has x. So the numerator has higher exponents and the denominator has lower. So then that means that I have no vertical asymptotes. So none for vertical asymptotes. And then I look and now I can talk back about my simplified one. I can cancel here. So that tells me that x equals -4 is a whole because it's gone. And then that means that I have no horizontal asymptotes. All right, so I just have a hole in my graph. So that creates it a little bit trickier on deciding what should we have in our table. It's for our XY. So let me go ahead and pull up my graphing calculator and we can talk about how do we decide. Okay, so take a look. I have my function put in there, and I'm going to go second table, and oh, there we go. It pops up with my hole at -4, which is what we found right over here. So I need to look at this and say, see, and if I scroll up a little bit, my numbers are going to go quite negative here that are going to be off my graph. In fact, I want to say that this one is going to be off my graph also, looking at my graph right now. So I would really start probably at just -5 and write -5, -9, and then go up a few. So that's going to make this look a little bit different. All right, so I'm going to transfer this onto my smartboard, and then we're going to graph it. All right, so if you do look here, it does indeed go off my graph. Not the best, but you know what, we can work with that. So that is how I decide where should I make my table, is kind of or where should I start my table on my paper, is I actually look at the table on my graphing calculator. All right, so I want you to go ahead and try this one and then see if you can have some similar results. And then when you come back, I will have all of it for you and we will talk about it. All right, welcome back. I have a hole at 1 and then my exponent, I have nothing left in my denominator, so that gives me no vertical asymptotes. And if I look at my exponents in my original problem, the denominator is smaller, the numerator is bigger, so then I have no horizontal asymptotes. So I just went ahead, this one fit really great in my graph, so I could pick 3 points to the left, I could pick 2, 3 to the right, and go ahead and graph those. All right, so just a heads up, when you get to your homework, there are 2 problems on your homework that have both whole and vertical asymptote and horizontal asymptote. So it can be done where you have all 3 of them. All right, have a great day, guys.